Hello, everyone. Welcome to this session, Extending BizTalk Services. This is actually the last session which we have in TechEd for BizTalk Services. We have one more tomorrow for BizTalk Server. So quick show of hands, how many of you have actually attended any one of the BizTalk Services sessions till now? Okay, nearly everyone, that's good. So this is the agenda for this session. I will just quickly go over what exactly is BizTalk Services. I'll go a little bit more in detail about what we have, what we call as bridges, and then the main intention of this session is to show you how you can actually extend BizTalk services using your code to cover gaps, which we don't have in our out-of-box offerings as yet in our V1. Okay, so this is a quick recap of BizTalk services. This is actually more like the component layer. So the basic building block which we have in BizTalk services today is this concept called bridges. I'll go over bridges a little bit more detail in the next slides. Bridges are the atomic units, but they need things like artifacts, which we call them. Out of the box, we currently support 4 types of artifacts: certificates, assemblies, schemas, and transforms. You need this to actually get your bridges working in an integration scenario. So bridges is like our platform layer component, so to say. Above bridges, we have built the B2B service. The B2B service, we expose B2B concepts like partners, agreements, profiles, partnerships. When you're working with the BizTalk services portal and you're working with B2B agreements and B2B partners and partnerships, when you deploy things like agreements, underneath the covers, we actually go and deploy the appropriate set of bridges with the appropriate configuration setup. On the left-hand side, you see these 3 boxes: BizTalk Portal, Visual Studio, PowerShell. These are the ways you actually interact with the EAI and the EDI layer for managing. On the right-hand side, you see monitoring store, tracking store. So these, when you create your own BizTalk services deployment, we actually ask you to give your own monitoring store connection string, your own tracking store connection string. These stores are actually going to reside in your subscription, and as the BizTalk services execute the bridges, the data which you generate gets stored into your store. So what is a bridge? A bridge is, like I said, it's the atomic unit which we have. It is actually made up of 3 smaller components, but all 3 can only exist together within a bridge. So you have sources, pipelines, and destinations. So let's go over what's a source. A source is literally your message source, from where your messages arrive and reach the bridge. Every bridge by default has one HTTP source. So whenever you deploy a bridge, you will be providing an HTTP endpoint, and that HTTP endpoint is where customers or your users can push in messages to get them processed through the bridge. You can configure multiple sources for a bridge, one HTTP only, and others can be FTP, FTPS, SFTP. You can have multiple FTP, SFTP sources for a single bridge. These 3 which you see here are the current ones we support out of the box. Destinations are where we finally send messages to after we finish processing them through the pipeline. The message will reach only one destination. You may configure multiple destinations for a bridge, but the message is going to get routed to only one destination, and which destination gets routed to depends on route filters. These are the current 6 destinations we support out of the box. Service bus, which includes actually service bus queues, service bus topics, and service bus relays. HTTP is your HTTP web services. The web service box, they actually should say WCF service. So you can actually configure a destination providing a WCF configuration. So you can talk to any web service which can be configured using WCF. We support Azure Blob, and again SFTP and FTPS. Pipelines. So pipelines are components which sit between the source and the destination, and they're the ones that actually are going to process your message as the message flows from one endpoint to another endpoint. A pipeline, think of it as a pipeline is a pipeline template plus its associated configuration. So if you work with BizTalk Server, in BizTalk Server, when you were used to create pipelines in Visual Studio, in BizTalk services, we call that piece as pipeline template. So your template is like defining the type of processing which this pipeline template is going to do. The template is composed of stages, and each stage is composed of activities. Stages, think of stages as they represent the intention of processing within that piece of the pipeline. So if you see in the diagram here, it's, we mentioned VETE. So this picture represents a pipeline template which has 4 stages. The V stage is validation. So the intention of this stage is that whatever activities you put within the stage are going to actually validate your messages. Then there's enrich, which is like enriching the message with properties, either from data which has come in from the context, like from the environment where the message was received. For example, FTP, like for example, the FTP file name. You might want to enrich the message using that information. You may want to enrich the message using data which is already in the message, so that you don't have to crack open the message every time, like using XPath. T is transformation. XML transform is one set of activities, one type of activity which you ship within the transform stage. And again, there's an enrich, so that if you want to enrich even after the transform. This picture here actually represents only a one-way pipeline. We also have two-way pipelines which execute in two-way bridges. So you would have a set of stages and activities on the request side, and also a set of stages acting on the response part. This picture represents just a one-way pipeline template. Okay, so I'll now show you a basic demo. Actually, how many of you have played with the two-way XML bridge, which we have in BizTalk services? Have you played with the one-way XML bridge? Okay, so in the demos which we have done till now, we've mainly showed you the one-way bridge which we have in BizTalk services. Before I actually get into the demo for extensibility, I want to just briefly show you the XML two-way bridge which we have and the features which it exposes. Okay. Okay. So I've created a very simple EA project here. When you create a new EA project, you get a surface which we call as the bridge configuration surface. On this surface, currently I have configured two XML bridges, two XML two-way bridges. So there's one which I've named here customer endpoint, one which I've named admin endpoint. So before I go into more detail here, let me just show you the artifacts which I've created. So I'm not actually going to run through this demo, like execute it. This is more of just to show you the features which we have in the bridge. So I've created some XSDs. So let's look at this one, external format. This has a set of complex size defined, purchase request, purchase response, query response, cancel purchase request, cancel purchase response. So the intention of this type, like with respect to the demo, is that you can have customers who are placing purchase orders, so they'll send a purchase request message, and they expect a response from the bridge, which is going to match the schema purchase response. Similarly, they can actually query the status of their purchase orders. For that, there's query and there's query response. And they can also cancel their request. So for that, you have cancel purchase request, cancel purchase response. So this schema, I've named it external format or XSD. This represents the types which end users are expecting, and they're going to send messages and expect responses corresponding to these schemas, these types. Now, in my service, I have my own set of types. So I just have this name normalized format or XSD. It has a very similar set of types, except that my backend systems, which are actually going to process these messages, are going to expect data using in these types. So I've named them normalized purchase request, normalized purchase response, normalized query, and so on. So the bridge which I'm going to show you in the demo is going to transform the message from the external format which the customer is sending to the normalized format which the backends are going to expect. Okay. So in my bridge configuration surface, you see two bridges here. So the intention is that in the customer endpoint bridge, customers, when they send messages, they will send messages only for creating a new purchase request or for querying the status of a purchase request. They cannot cancel a request. If a customer needs to send a cancellation message, he's actually going to use he's going to send a message to the another endpoint, which I represent here using this admin endpoint bridge. So that's why you see two bridges here. Another thing you see is that these two bridges are both routing messages to two destinations. One destination I've named here VIP customers, and one is named other customers. So customers who are VIP customers, their messages will get routed to a different endpoint from the other customers. So if I'll just open up the XSD again. So the purchase request type, you see, it has a customer ID, an order ID, and an amount. And we will see in the demo how we actually figure out whether a customer is a VIP customer or not using this data, and how we transform it to the normalized format. So I'm first opening up the customer endpoint two-way bridge. So this is So this surface represents the XML two-way bridge. You see on the left-hand side, the stages validate, enrich, transform, enrich. These represent the request path of your bridge. On the right-hand side, you see enrich, transform, enrich, send reply. These are the stages which we have on the response side. So you see the message is going to flow in this fashion, like how these arrows display. At the end of the request set of stages, the message is then going to be routed based on route conditions, which we will see in the bridge configuration surface here. And once we get a response back from these endpoints, the message then flows back across the response path of the bridge before we finally send the response back to the client. So this is the two-way bridge. In the design surface, the way we have it is that think of the bridge as you're kind of defining your service where you specify the request types which your customers are going to send and the corresponding response types which they expect back. So I've added this one entry added here. You see on the left-hand side here, it says purchase request. So like this is the request type which we expect we'll get into the bridge. And the bridge is going to give you a response back, purchase response. So this is my customer endpoint bridge. So as I mentioned that the customer endpoint bridges accept two types of messages. One is for a purchase request, one is also for query. So if I want to have this bridge also support the query message type, you click this plus sign here. This shows you all the available XSDs you have in your project. Let me choose query here. So this query message type is what I want to allow in my request. And the response for this is going to be query response. So I choose query response and I click this arrow here. And so I've configured one more request message type and the corresponding reply message type which I want to allow in this bridge. If I click OK, you now see two of these showing up here. In my project, you also see there are a number of TRFM files. These are the transforms which are going to transform the various message types from the external formats which customers send to the normalized formats. So I actually have one transform for every combination which I need. So if you see there's a purchase request transform which is transforming from purchase request, which is the external format, to normalized purchase request, which is my internal format. Similarly, there's a purchase response transform which now transforms from the normalized purchase response to the purchase response. So in my message flow surface, if you see, customers will send in messages in the customer format to a customer endpoint bridge. The bridge, when it routes to my backend services, it has to route back in my normalized format. My endpoints backend are going to reply back again in my normalized format responses, and then the normalized format response has to be converted back to the customer reply format. Is that clear? So that's why the purchase response transform is going to transform from the normalized purchase response back to the external purchase response. Similarly, there's a query transform which transforms from external query to normalized query, and then there's a query response which transforms from normalized query response to external query response. Okay. So when you come back to the bridge, we have specified the two types of messages we want as inputs and the corresponding reply types. So by default, if you click on this validate stage, you see that there is no way to actually specify which schemas you want to validate against. The current design is that whatever types you have specified here in the bridge at the top, these are the types which you are going to validate. So think of it as implicitly, we will only allow messages which match these two, purchase request and query on the request side, because that's what you have configured. Yeah?
So does it matter in what order they give these messages?
No, the order does not matter. It's just think of it just as a collection of request schemas and the corresponding response schemas.
So like let's say if I have some 10 items there,
Yeah.
and bulk of my messages are of the 9th type.
Okay.
Does it matter, like I have the 9th flow question?
There is no effect on performance or functionality. The order does not matter. Okay, before I come to enrich, let's look at the transform. So in the transform stage, we currently have only one activity, which is XML transform activity. Here you can configure the maps which you want to use here. So I showed you before that there's a purchase request TRFM, there's a purchase response TRFM, there's a query and a query response. There's also, if you see, I also have two maps which do the similar thing for the cancel purchase request and the cancel purchase response, right? Like I said, the admin users, they will send messages to cancel the request. Again, the cancel request message has to be transformed from the external format to the normalized format. The response has to be transformed back. So I have corresponding maps for those two. But if I go to the XML transform activity, and if I configure the maps, you'll see that the only maps which show up are the maps which we have identified that these maps, their source message types, belong to the set which you have configured on the request message type. So for example, the cancel purchase request map and the cancel purchase response map, those don't even show up in the list because you've not specified that I want to allow cancel purchase request as input into my bridge. So we have automatically filtered from all the maps in your project, only the maps which have the request message type as your source. So in this case, if you actually see, I didn't show you before that there's a purchase request map, which again maps purchase request from XML format to normalized format. Similarly, I've added just for demonstration purposes of a map called old purchase request. Think of this as a previous map which I had designed. It's in my project system. I don't want to use it as yet. So it shows up in the list here, but if I don't tick it, we are not going to use it at runtime. So I have purchase request and purchase request map allowed. I'm also going to choose query because I want to allow both purchase. I want to transform both purchase request and query in this bridge. And I can click OK, and these maps are now these are the maps which are going to be used. Similarly, on the response side, if you see, just come to transform response. Again, the maps which we show you here are the ones which. XML transform on the response side, I choose maps. We again now filter from all the maps in your project system. We only filter and show you the maps where the destination is going to match one of the responses which you want to give back. So again, since over here you see that we have said that the destination type, the response types we'll give back out of this bridge are either purchase response or query response. We only show you those maps which you have in your project system, which actually are going to transform something into purchase response or query response. So similarly, I have one tick here to show that I want to use this map. I'm also going to say I want to use the query response transform. Okay. So that's transform. Now we come to the enrich stage. The enrich stage in the out-of-the-box XML bridge which we have in the BizTalk services, the enrich does three types of enrichment to the message. We have a single UI here which combines everything, but underneath the covers there are really three types of enrich ways. So let me show you, just bring up this UI. Okay. So one question. Not currently. So we'll only pick one transform and we'll just execute that. Okay. So the three types of enrich we have. The first type we think of it as like a protocol enrich. So you're enriching the message. Enriching is you're adding some promoted properties to the message, and the value of this promoted properties comes from what we say as protocol. Like it comes from the HTTP headers. It would come from SOAP headers. It could come from things like, for example, when you're pulling a file from FTP, it can include things like the FTP file name, the FTP folder path. So this enrichment is the values which you get for the promoted properties are coming from the protocol and how the message was received. So in this dropdown, you will see SOAP, you will see HTTP, FTP, SFTP. There's also something called system over here. So there's some system properties which you can actually use and promote properties from. There are currently 4 types of system properties which we have: request ID, message receive type, source name, source type. Okay. So let's look at each of them. Request ID. So every message which reaches a bridge, we actually stamp a unique request ID on it. That request ID is what we will use when we generate tracking data, when we generate traces, and in case an error occurs in the bridge and the client gets back an error message, the error message is going to contain this request ID. So this request ID is unique for every message reaching a bridge. you can use the request ID and you can promote a property where you say that I want to promote a property named X. Actually, let me show you here. So I'm saying I want to add a new property. The source of the property is the system properties and that identifies the request ID. I want to promote this value to a property named, let's say P1, and data type is string. So these are the 5 types you support. So what this means is that I'm saying that at this point in the flow, I want to promote a property named P1 of type string whose value is derived from the system property request ID. Similarly, if I say I use SOAP over here, again, I can specify a SOAP standard SOAP header like action, message ID, reply to 2. I can even specify a custom SOAP header, let's say H1, and I can specify the namespace of the SOAP header, and I can promote this to a property with any name which I choose. So this is the protocol enrich, if you will. The second type of enrich which we support is enriching the message from data within the message, which is usually done by, like since it's an XML bridge, the message is expected to be XML. We support XPaths. So you can actually choose XPath over here. We show you the available purchase, the available message types you have, and you can specify the field within that. So if you see here, I've actually already promoted a property, the customer ID property which we saw in the purchase request message. I've promoted that. The property name is also called customer ID, and data type is Boolean. Oh, sorry, it should be string. Okay, so I've promoted the customer ID property here. The third type of enrich which we support in V1 is what we call as lookup. So we had some scenarios from some customers where they actually had like a lookup table in a SQL database. So they get data from the message or from the context like the protocol properties. They need to actually go and look up some value in a database and get some data back and promote that as an additional property on the message. So think of it just as like a key value lookup. So out of the box, we have support for doing key value lookups on SQL databases. So here I've configured a property. I'm saying that this is going to be a lookup. This property's value is going to be derived by doing a lookup. The identify. Okay, here identify represents the information regarding your SQL connection, your SQL database. So let's say if I configure new, we actually ask you to give us the information regarding your SQL connection string, your table name, and like since it's a key value lookup, we actually ask you for an input column and an output column. So I'll come to what that means. The lookup property I specified as customer ID. So what this means is that when I do a lookup into my SQL table and I've specified input column is X and output column is Y, the query will execute is find the row where the input column X has a value equal to customer ID and the value of the output column Y, put that into this property name here is VIP of data type Boolean. So what I'm really doing is, given the customer ID from the message, I'm going to do a lookup in my SQL table that says, for this customer ID, get me information whether this customer is a VIP customer or not. Okay. So just to repeat, because it's a little complicated, there's one property P1 whose value we are going to use to find which row in the SQL table has the key column having that value, and the value of the value column is what we're going to actually promote as another property in the message. It sounds confusing. When you play with it, you'll get used to it. It is similar to lookup of functorial map, yeah. Okay. So I've configured these two properties here. Okay. So this kind of completes my request side of the processing. I've already showed you the transform on the response side. Okay. So now when I go back to my bridge, when I go back to the message flow surface, so I want to have it such that VIP customers, their messages get routed to this endpoint, while all other customers, they get routed here. So I've configured a route condition here that says is VIP equal to true, and what I've configured here that is, if you see, it says filter condition 1 equal to 1, which really means match everything, right? So what I really want to do is I want
Match everything doesn't fit into VIP equals to.
So I'll come to that. So as I mentioned earlier, we will, if you have multiple destinations configured for a bridge, we only route to one destination. The order in which we actually evaluate the various filters for various destinations is something which you control. So if you see here in the route condition, there's something actually mentioned here called sequence number, like this filter condition and the sequence number. So sequence number 1 means we'll first evaluate this filter, and if you look at this other filter, other predicate here, which says match all, it actually has sequence number equal to 2. So only if the message, based on the message properties, we do not match this predicate, are we actually going to come and evaluate this one. So all VIP customers will match this condition, so they'll all get routed to the VIP endpoint, and all other customers, we don't do any check, we'll say, okay, this, because it's a match all filter, route it to the other customer's endpoint. Okay, so in route, you saw we have filter condition, we have sequence number, we also have this thing called route action. So I won't actually configure here something, but I'll just talk about this. So as you saw in the enrich stage, we specified using which protocol like HTTP or SOAP, read the value from that location, if you will, and promote a property. In a route action, you actually do the reverse. You take a property which you've already promoted, and you use that value to write it back as a SOAP header or a FTP property. For example, you could control the FTP file name or an HTTP header. So in this case, we show you these two properties which you have promoted. You have promoted the customer ID and SVIP property, so these two show up in the list. These two are actually system property, well, I want to say system, these are properties which the XML bridge automatically promotes. This represents the current message type. Like in BizTalk, for example, the message type was like namespace, hash, root node name, right? So X pipeline message type, X pipeline request message type. The request message type represents the type of the message which originally reached the bridge, and message type represents the current message type of the message. So I can actually say, so let's say I want to pass on this isVIP value to my backend service. I don't want to actually, let's say, I don't want to pollute the message data, but I yet need this information to flow to the backend for whatever reason. So actually I can say, okay, choose isVIP and write this back to either HTTP or a SOAP header. So I can say, let's say if I say HTTP header H5, when this message goes out, there'll be a header, HTTP header named H5, whose value is the value of the isVIP property. Okay. I'll just come back to the bridge to show you that what I just showed you now in the route action, there's a similar thing which you can do on the response part. Here it's called like reply action. So similarly, after when the message is when your response message is finally going to get back to the end user, you can again you can write back properties over HTTP or HTTP or SOAP to the client. So I've configured here to say that the SVIP property, I want to set it back as an HTTP header, which is also named SVIP. Just a few more concepts to show you here. So if you choose a bridge here and the route ordering table is the one which actually shows you the available route, the route conditions you've currently defined in your message flow surface, and here's where you can control which one should be number one and which should be the second, and so on. Track properties in this collection is where you actually configure tracking for your bridge. So by default, we always track any errors which occur. You can optionally choose to say that you want to track all message processing events. So for example, then we will track pipeline started, pipeline ended, state started, and so on, those events. You can also control which message properties you want to track. So we have currently identified based on your bridge configuration that you have that these 4 properties are going to currently be available in your bridge, right? So we show you these 4. You can either say I want to track all message properties, in which case every tracking record we emit is going to emit the values of these 4 properties at the current point in time. Or you can say, I want to just specify exactly like I want to track only these 2 properties if you want to like reduce your tracking payload. Okay. So that is it for the simple demo for the XML bridge. Now we'll actually go back to the real extensibility demo which I want to show. Let me close this. Okay. Let me first show you the demo scenario. Okay. So the end solution which I want to build using extensibility is I have an Excel file, an Excel document which has information about leads. I need to get this lead information from my Excel document into an online SaaS CRM application, and for the purpose of this demo, I'm going to use Salesforce. There are multiple ways to do this. There might be simpler ways which CRM applications have out of the box. The purpose of this demo is like I wanted to keep it simple to highlight the extensively points and not to dwell too much on the actual demo itself. So in this case, an Excel document, what you have to do is you have to, since this is an XML bridge, we need to convert the Excel data to XML so that we can use XML validation, we can do XML transformation. We then need to transform the data to the CRM format, and then we finally need to get the data into the CRM application. So this is the end demo, this is the end application which we want to build. We'll start off with a pre-built application which currently does something much simpler. It has a bridge configured here. This bridge is only going to accept XML messages, and this bridge currently routes messages to a service bus relay endpoint. Okay? So we need to enhance this guy to finally get our end-to-end application working. So just to show you how this currently works, I have a small tool written, a send to bridge exe. It's going to just push a message using like HTTP web request to the endpoint which I specify. I've already configured the endpoints and all in a config file. So what I'm just going to show here is that I want to send I'm going to send an XML file. I'm going to specify the content type of this message. Like this is going to be a simple XML message. So content type is application/XML. And this is the message which I'm going to send to my bridge. And this message is going to So in my current setup, I'm routing to a service bus relay endpoint. So I'm starting my on-premise service here, which is exposed to the cloud via a service bus relay. In this bridge, let me just show you. There's a single message type which I expect. It's lead. It has these 4 properties here. This is in my schema. This is a one-way bridge. So all you see here is the request stages. You don't see the response stages. Okay. There's no transform, there's nothing else here. All you have is a single XSD defined, which means that all we will do here is validate. We will not transform because there is no map defined. Okay. So let me just first quickly go ahead and deploy this. You right click deploy. I have this information already filled up. I just click deploy. It deploys the artifacts which I'm using, in this case a simple XSD, and it deploys the bridge and says everything successful. Before that, let me just show you this is my XML file, which I'm going to send. Oh, no filter matched. Oh, I'm supposed to change this. So this is supposed to be match all. So whatever comes out of the bridge is going to get routed to this destination. I will have to deploy again. Let me send it again. And here you see the output, the message which I received from my on-premise relay service. One thing you'll notice is that the XML file which I showed you was this one, like a very simple XML file. But what you actually see here is, if you look at it, it's like an entire SOAP message. The thing is, I've configured this relay endpoint to use, I think it's the basic HTTP binding, which is like a SOAP binding. So internally, the bridge, when you're routing to an endpoint, we can convert from a POX message to a SOAP message or vice versa. We'll determine what format to convert to based on how we've configured a destination. So given that I've configured a SOAP destination here, we've converted it to a SOAP message, and that's why you see a SOAP message being received on the side. Okay. Now let's look at how we can extend this. So this is the bridge diagram I showed you earlier. You have sources, pipelines, destinations. There are currently 3 places at which you can write custom code and extend bridges. The first is what we call as message inspectors. Using message inspectors, you can actually write your custom code which executes in between stages of the pipeline template. So, for example, in this case, there's a VETE on the request side and similar response side. You can write your own code which executes either before a stage or after a stage. The second point, the second extensibility point which you have today is within the XML transform activity. So within the XML transform activity, we have a C# scripting functoid where you can write a single C# method which can be used to map from a set of source elements to a set of destination elements. The third extensively point which we have is, as I mentioned before, the web service destination which you have is really, it takes in the WCF configuration. You can actually write your own custom, you can use WCF extensibility, for example, like writing your own WCF binding, a binding element, a behavior, and you can use that to extend the destination. So what we're actually going to do is, we are going to rewrite one message inspector, which is going to convert from Excel to XML, because, well, out of the box, we don't support Excel documents, right? Out of the box, we have support only for flat files and XML messages. So we need to write a message inspector which can convert from Excel to XML. We will then write some custom code which executes within the transform, which is going to help us in the transformation from our lead XML file which I showed you to the format which we need to send it to Salesforce in. And then I'm going to use WSL extensibility to write a simple behavior which I can use to configure, which I can use to work with the Salesforce authentication mechanism, because like it's a custom mechanism. And I'll hook that into the WCF destination, and that's how we'll finally get the message to Salesforce. So message inspectors. As I covered, message inspectors execute user code between stages. When your message inspector is called, it has access to your message, which means it has access to the body of the message and it has access to the promoted properties. You can both read and you can write, which means that you can completely change the body, and you can also, for example, promote your own property. You can remove a promoted property if you wish from your inspector code. One of the features which we enable for BizTalk Services 1.0 release is that if you actually have custom traces which get emitted within your from your message inspector code, we will collect those traces and we will show you those traces in context of the other traces. For example, when your message is executing the validate, the enrich, the transform, and let's say you wrote custom code that executes after the transform stage, you have access to all the traces. The traces will say, okay, executing validate with whatever trace statements we emit, executing transform, executing enrich, and then you'll see in between those traces, you'll see your trace statements which we have emitted. So it makes it much easier for you to figure out that, okay, for this message, which was being processed through the pipeline, what are all the set of steps which have happened. As I mentioned before, that we have a request ID, which is unique per execution. So the request ID is what you will use to correlate your traces with our traces to understand what is happening in your message inspector. Okay, so let's look at the demo for message inspectors. So this Excel to XML project you see here is actually representing my message inspector. I've abstracted out all the code related to the actual conversion from Excel to XML. Okay, so before that, let me just explain to you what the Excel to XML component is going to do. So this is my Excel file. It's like a simple form where you can enter lead details. Think of it as this is the point where your end user might be entering in lead information into an Excel file, and this is what you want to have processed within your bridge, right? Excel has a feature where you can actually associate an XSD with an Excel document. So if you see here, I've associated an XSD with it. This XSD is similar to the XSD which I was using in my bridge. I can map the various fields in the XSD to various values here. I can use the Excel application itself to say export this data as an XML file, in which case it will pick up the appropriate values from the fields here based on the XSD defined, and it will emit an XML file. But you don't have the Excel application running in BizTalk services, right? So you need to write your own code which can do this. In my inspector code, what you'll see is I'm using the open document, open XML SDK, which allows you to access the Excel file. Using the SDK, you have access to both the data and you have also access to the XSD. So the component which will write the message inspector is actually going to look at this Excel file, figure out the XSD which was used inside this Excel file, because that XSD is embedded within the Excel file, and looking at that XSD, generate an XML document with values which are filled in an Excel document. So I've abstracted out all the code that does the actual conversion, just to highlight only the inspector related code. So when you're writing a message inspector, there's a simple interface you implement, which is called the iMessage inspector. This actually has only a single method called execute. You have as input the message, which represents a message at that current point in time in your bridge, and you can directly modify it. So the logic here is, this is the logic for the inspector. We are actually first going to check what is the content type of the inspector. what's the content type of the message. For example, if someone has sent us an XML message, we don't really need to do anything on top of it, right? It's already XML, so we can just skip it. So here you're checking that if the content type of the message is the Excel content type, which is this whole string, then let's do some conversion. So this is my helper method, which does the conversion. I get the next XML message out of the Excel document. I assign this message to the message data property. So let's quickly look at the iMessage structure. It has a content type field. It has a stream field. It has a data field of type stream, and then you have access to the promoted properties. You have access. You're able to actually promote your own property. So this is a simple iMessage interface. So here I am assigning the body using what I got back from my Excel to XML helper converter. I'm now changing the content type of the message. Like earlier it was an Excel document, so the content type was this big string you see here. After converting an Excel message, it's now an application/XML. So I'm changing the content type, and I'm just emitting a trace statement to just indicate that things were successful. Okay, so let's now use this inspector in our bridge. So another thing actually I want to highlight to you is, which I didn't do before, is that when we mentioned that the destinations which we support out of the box, the 6 destinations which you saw, right, HTTP and web service and FTP and all, we also support you routing a message from one pipeline to another pipeline. We call it pipeline chaining. So let's say, in this case, what I'm going to do is I'm going to leave this bridge untouched, which is working in XML. I'm actually going to use the pass-through bridge in front of it. The pass-through bridge is called a pass-through bridge primarily because out of the box, it does not affect the message body. The only thing you have in the pass-through bridge is the enrich stage, which is just used to promote additional properties. Right? It doesn't touch the body out of the box. Of course, you can write your own code like message inspectors where you start modifying the body. So I'm going to actually configure this bridge with the message inspector, and then I'm going to actually just route this over here. So let me first set up the route condition. This is going to be a match all, so everything just goes through. Let me set up the address for the bridge. Okay, so the error you saw there was every entity on the surface is supposed to be uniquely named. So let me just call this TechEd demo 2. And the address of this bridge is going to be, okay. So one thing I should mention, we covered this in today's earlier session. When you set up a message flow, when you set up this bridge configuration surface, you specify the URL of your deployment. So it would be, so I'm using an internet environment, so you see something like BizTalk ICBCS1.windows.inlet. Is this visible from the back? Let me do. So the URL is representing your deployment URL. So the endpoint for your bridge is really going to be a combination of your deployment URL, the namespace. Currently in BizTalk 1.0, we only support a single namespace, which is by default. You cannot change it. So the URL of your bridge is going to be this thing here, followed by /default, followed by the path or the endpoint address for your bridge. So in this case, the bridge's endpoint is this. Okay. So when I send my Excel document, I should actually now start sending my Excel document to this bridge. Okay. I've yet not configured the message inspector here. So the way you do it is, you need to specify. Okay. So here within the stage, as I mentioned, you can have your inspector execute either at the beginning of a stage or at the end of the stage. So there are 2 fields here: an on enter inspector and an on exit inspector. So what you specify here is the .NET type of your class, which represents your message inspector. So let me just quickly insert this. So I specify that this is my type, which is represent my message inspector, which has to execute over here. What I also need to do is I now actually need to deploy my custom code assembly, right? Like I need that to be deployed in BizTalk services so that this type at runtime is found. So what I'm going to do is I'm going to actually add a reference to my DLL, which has my inspector. This has a dependency on the OpenXML SDK, so I should add a reference to that also. In your EA project, as I showed you before, when I did a deployment, we had deployed the simple XSD and the bridge, right? If you want to deploy .NET assembly, all the references which you've added, you should make sure that the copy local field is set to true. So from all the assemblies which you have as references in your project, the ones which have copy local equal true, those are the assemblies which we are going to deploy when you deploy your bridge. So in this case, I need to deploy my Excel to XML DLL, and I need to deploy my Open XML DLL, right? Okay, so this bridge is now set up. I've configured the inspector. I've configured the route condition to say match all and send everything to this bridge. Let me go ahead and just deploy this bridge. So this is actually going to deploy everything in the project. So it's going to deploy the XSD as well as the assemblies and also both the bridges. Okay, so everything deployed successfully. Let's now send our message. I need to make one small change. My code was first sending message to the XML bridge. I need to just change this to say send it to the other bridge which I just created. And send to bridge.exe my Excel document, which is the file which I want to send. And I should also specify the content type. So the content type of an Excel document is this. My relay service is stopped, so let me just start it again. Okay. Okay. So what you see here is again an XML file. So what actually happened was we sent the Excel document, the first bridge converted it from Excel to XML. This XML is the same XML, same format as what we were expecting in our second bridge, so it has passed validation and it has successfully routed to the destination. So what you see here is the same XML as before. Okay, so this is inspectors. So this is a simple how-to. There's a single interface which implement the iMessage inspector interface, which is defined in this DLL, which is part of our SDK. Once you write your inspector code, you compile it. You can either upload the DLL from the BizTalk services portal, or if you're doing it from Visual Studio, you can add a reference to your DLL and we will upload it during deployment time. On the bridge config surface, when you're configuring a pipeline, you make sure that you specify the type name of your inspector at the appropriate location, like between whichever stage you need to do it. So one thing which I haven't covered in this demo, which I mentioned here, is that we actually also allow you to specify configuration properties on your message inspector, which you can specify during configuration. So if we come back to the demo. So when we specify the type name of the bridge here, of the inspector here, we specify a type name here. There's also like a multi-line text box here where you can specify configuration properties. And these properties will be available, will be set on your inspector code as it executes. I'll just show you how you do that. So here, this is like a very basic inspector. So if you see here, I've specified a config property named config property 1. I've put an attribute that says pipeline property, which means that the value of this property when your inspector's execute method runs is going to be set from the value which you have configured in the bridge configuration surface. So that's how you can actually also have configuration flowing to your message inspector. In your config surface, yes, it's a property bag. It's like a multi-line field, so you do A equal to B, next line, C equal to D, next line. So that means we expect there to be two properties, A and C, and the values of them will be B and D when we execute the inspector.
Is there any validation there depending on, like, let's say, config property 1 needs to be case sensitive, Java case?
Yes, the names have to match. Names are case sensitive; they have to match. If there are any errors, like in data type conversion, for example, let's say you've configured this to be int, and the value you've configured is like something is not integer, right? That error you will get only at runtime, right? But the names have to match, yes.
So does it give a real-time error if I have a bad variable name?
I'm not sure, but you'll find out soon enough when you run it, right? So some things to just keep in mind when writing a message inspector. Okay, the first thing, uniquely name all config properties. Make sure you don't have two config properties with the same name. Always rewind the stream after you set it, update the message data. Set the content type to match data. So the reason this is important is because, as I mentioned, out of the box, we have support for things like for XML and flat file, right? Even if you see my message inspector, which I wrote here, my logic assumes that, okay, if the content type is something, that means this is an Excel document to do something, right? So many of our activities expect the content type to indicate what sort of message this is. You don't want to be in a situation where you wrote the Excel to XML inspector, you converted from Excel to XML, but you did not change the content type, and the content type gets says this is an Excel document, right? Further down the line in the pipeline, you will hit some errors. So always make sure that you update the content type to match the actual data which you have. Use APIs that can work irrespective of the bomb being present or not in the message stream. So the reason I mention this is because depending on how you write your inspector, depending on how we have written our code, like there are various APIs in the framework, some of them will actually emit a bomb, some which don't emit a bomb. When you're reading the stream back, some of them expect a bomb, some of them can work with either, and some don't expect a bomb. If your APIs you use are not proper, you might get an exception. For example, if you have an API which does not expect a bomb, expects just the XML, like the XML tag to start off, and if there's a bomb in your stream, you'll actually get an error, something like do data invalid or something like that. So like a few of our customers actually hit that, so I try to highlight this here. And make sure your APIs can work with either a bomb being present or not. So one thing which I haven't showed you here is that when you deploy assembly, so we have in our service, we are going to load your code and we are going to execute it, right? Now let's say you've already uploaded your inspector and now you need to make a bug fix, and now you need to upload the DLL again. In .NET, as you know, you cannot actually unload an assembly once it is loaded, right? So what you actually have to do is you need to restart the service. So you trigger the restart. When you trigger the restart, what we will do is we will restart the backend service, and we will pick up the updated assembly which you have deployed. You can restart in two ways. One is using our PowerShell commandlets. In VS, if you remember in the deploy wizard, there was actually a checkbox at the bottom that says refresh service. So if you check that box, after you do a deploy, we will actually go and trigger a service restart. So when the service restarts, it will now pick up the newer version of your assembly. Make sure the assemblies you upload are strong name signed. If you upload an assembly which is not signed, we will actually reject it. Okay, I'll show you the second part. View traces in the VAD logs table. So as I mentioned that when you actually create a BizTalk deployment, we actually take from you information regarding the monitoring store, which is an Azure storage account, and we take information regarding the tracking store. So tracking data is available in the tracking store, which is a SQL database. In the monitoring store is where you will see your traces getting generated, traces getting emitted. So in this case, when we ran the inspector, we saw a statement that said, executing from TechEd. So we expect that trace statement to be available in the store. So I have this Azure Storage Explorer here. So in the diagnostic store which you have provided, there will be a table called the VAD logs table. This VAD logs table is what is also used if you are directly using an Azure worker role. So if you are writing against the Azure worker role, there's an API they provide called diagnostic store or diagnostic monitoring. The traces you emit get stored in the VAD logs table. We are following the same model. Whatever traces that get emitted, we store them in this table. So if you want to diagnose issues, for example, you want to debug something that why is my inspector not working as expected, the first thing to do would be to come and look into this table. This table is slightly difficult to use in the sense that queries on Azure tables are efficient only if they are on the partition key or the row key columns, right? There's a timestamp column which actually represents the timestamp at which an entry got inserted into the table, but if you query on the timestamp, it's not going to be efficient. You need to query on the partition key or the row key. The way the tracing mechanism in Azure works with VAD logs and with the diagnostic monitoring is that the time at which you emit a trace statement, they use the ticks of that date time, they add a 0 in front, and that value is what is available, is what is used to create the partition key. So before I actually started the demo, I ran a small tool which just, for the current UTC time, it just got this value here which represents the date time ticks. I'm going to use this as my partition key and query for all records which have been emitted after that time, because my demo just ran now, right? So we expect the traces to be here. Okay, I think somebody else ran some demo a while back, so let me skip through some of this to find my traces. Okay, so I see here TechEd extensively demo. So these are the traces emitted when we were running our bridge. So as I mentioned, that the request ID, which is unique, if you see all the trace statements here, they all have the request ID field here. So for every message which goes from the bridge, there's going to be unique request ID field, request ID value. You can actually use that to correlate that from all the traces which get generated here, which traces correspond to a specific instance of execution. So somewhere here, we should be seeing our trace statement. Let's see where it is. So actually you see things like, pipeline activity started, pipeline activity ended, begin execute, end execute. So everything is here. Our traces, your traces, error messages. So when you have to diagnose, it's quite simple to diagnose. Or actually it's easy to just get to the traces. So let's see where our trace statements are. Okay, if I can't find it in the next 2 seconds, you can just trust me that this trace statement is supposed to be somewhere here. I think, okay, I saw it. So here's the trace statement. So the message first reached our pass-through bridge, right? And then it got routed to the XML bridge and it got routed to the final destination. So you see your trace statement says here, message was received by template pass-through pipeline with some request ID 678 blah, 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 blah. Now you see all the statements which are for that instance execution have the same request ID value here. So in the pass-through pipeline, as we saw, there's only an enrich stage and an enrich activity. So it says here that this enrich stage it's called the request message extractor stage. And then we actually found a pipeline message inspector to execute. So that's our Excel to XML conversion inspector. And here you see the trace statement says information from TechEd live successfully converted. So this is our custom trace statement which we had in our inspector, which you see here. So this is how you would actually get access to the traces if you want to debug an issue. Okay, so now the next extensively point, which is XML transform. There are 2 ways you can actually extend, you have your own code executing within XML transform activity. One is you can actually provide the entire XSLT yourself. If, for example, you have an XSLT from some previous application or from BizTalk server, you can provide XSLT yourself. You will just run with that. Or you can use a C# scripting functoid to write your own C# code. So let's extend the demo further. So in the XML file which I showed you earlier, which is our lead information, there's a last name, there's a first name, there's a company field, and there's something called contacted, which can have a value of yes or no. At least that's the XSZ which we have defined. So this yes or no represents whether this lead has been contacted or not. In Salesforce, when you insert a lead in Salesforce, they don't actually have a contacted field. They have something called status, and the status value is either yes, contacted, or no, not contacted, or something like that. So we are actually going to use the C# functoid to actually convert only the single field contacted from the value which we have in our format to the value which Salesforce expects. So let's go back to the demo. In this bridge, we currently are taking in this XML file in our format. We now need to transform it to the Salesforce format. So I already have the map predefined. Let me just add it here and then we can have a look at it. Okay, this is the map. The last name, first name, company fields are just straight line mappings because they don't change. If you look at this guy, here I'm using the C# scripting functoid. So I've written a simple method. It says string contacted is the input method, is the input parameter, which represents this value coming in from here. Simple C# function says if contacted value is equal to y, set the status to working contacted. If it is no, set it to open or contacted. Return status or return type is string, and the string is mapped. It is going to get the value of the return value is going to come to the status field, right? So this is the simple C# functoid. Let me just go and quickly get it working. I just need to configure the map here. I'll deploy again, but just as an optimization, let me go and set these guys to false because I already uploaded the DLLs in the previous deployment. I don't need to upload them again. This is the checkbox I was telling you about, refresh service after deploying, which will restart your service after you upload the DLLs. Okay, so deployment is successful. So if you see in the previous output, it said first name, last name, and contacted no RES. Now when we run it, let me just start my relay service again, which is going to get the message. Let me send the message again. If you see here now, the value of this field is no longer Y or N, it's actually open, not contacted. So that was our XML, C# scripting functoid in action. Okay, so how to? You define a single method in your scripting functoid. It can only have input arguments. It should not have things like ref arguments or output arguments. Every argument which you have represents one link on your surface. So this is the order in which the links will show up, and you can of course control the order. And so each entry here is going to map to one input parameter. Input parameters can only be primitive types. They can also be X element. So for example, if you have mapped, like let's say a parent node which has some child elements underneath in the source XSD, if you have drawn the link from your parent node to your C# scripting functoid and you specify the type as X element, what that means is you will have the entire subtree in the source message available in your functoid. Was that clear? So X element is a .NET type which represents an XML node which can have child nodes, right? So if you have mapped, okay, let me show go back here. If I had actually drawn the source link from lead instead of contacted, right? So lead is now a parent node which has child values underneath. And if I change this string to X element, the value of the X element is going to be the entire XML over here. So I can actually, I'm going to use as input multiple values at the same time. The return type from your method, again, has to be a primitive type. It has to be a single value. You can also give back an X element, which is again like an XML fragment. And this XML fragment, what you return back from your function is what we're going to use in the output message. So you could, in your custom code, you could actually write a method which gives back an entire XML fragment if you want to control like an entire subtree of the output message. You can actually also give back an I enumerable of X elements, in which case we will just take all of them and place them as is in sequence in your output message. Okay, that's it for C# scripting functoids. We'll now move on to WCF destinations. So as I mentioned that since when you're using the WCF destination, which you have, you actually specify a WCF configuration, in which case all the options for WCF extensively are available to you. You can add your own custom behavior, your custom binding element. So let's look at that quickly. So in our demo, what we're now going to do is we are taking an Excel document. We've already converted the Excel document to an XML. We've converted the XML to the Salesforce format. The only piece remaining now is to actually send the data to XML instead of my relay service, right? So for that, we will use a custom behavior to add the appropriate authorization headers to the output message, and then we'll send that message to Salesforce. So this is my Salesforce WCF behavior. I'm highlighting here only the parts which are relevant to the behavior. So I have a class which derives from my endpoint behavior, which is a WCF extensively hook. In my behavior, I'm going to add a client message inspector. A message inspector in WCF is that when the message is going to go over the transport, over the binding, before it reaches there, the message inspectors which are added have access to the message, just like how we have in pipeline message inspectors, right? So you have your message object. You can again go and modify the message object as you wish. And the return and the output from your inspector is now what is actually going to go out over the WCF channel stack. So again, I have a helper method, which is going to take my Salesforce username password. It is actually going to use the Salesforce algorithm, the Salesforce protocol to get the appropriate security token, and I'm going to just stamp this token onto my message. So this is my WCF behavior here. As we did before, I need, since this is going to be a custom code, a custom type which I've implemented, I need to again upload this DLL, so I'm just going to add a reference again to the Salesforce behavior. Okay, now in my bridge config surface, which is currently routing to this one-way relay service, I need to change it to actually talk to Salesforce. So let me use a external service endpoint here. Just call this Salesforce endpoint. And this, when you double-click a external service destination, you get this SVC config editor, which is an out-of-box tool with the .NET SDK for working with config files to create set up the WCF endpoint configuration. So in this case, actually, let me open the config file here. I already have the whole thing set up. So I have a WCF endpoint configured here. It's named this. The address of the endpoint is the Salesforce URL where I would have to send a message to if I want to insert a lead. I'm using the web HTTP binding. I'm using REST because the Salesforce format requires the message to be in REST. I've configured my behavior, Salesforce authentication config behavior. This behavior is actually, if you see, it's defined here as a WCF extension. This is my Salesforce authentication behavior. This is my type, which was my .NET type, which I just showed you here. And I've configured my username, password, and stuff. I need to now route message here. Let me again just set this as match all. But because this is sequence number 2, the messages are going to match this match all first. So let me just change this to say 1 equal to 0, which means it's always going to value the false, right? Okay. Let me deploy again. Okay, so this bridge is deployed. So what should now happen is when I send an Excel document, it'll get converted to XML, it'll get mapped to the Salesforce format, and then finally I should see the lead information showing up in Salesforce. So this is the Salesforce page where the leads show up. As you see now, the lead information which I was inserting is not here. Let me send the message. Okay, so one thing here, as I mentioned, right, the request ID, which is the unique ID per instance execution, whenever you send a message to the bridge, the response message which you get back is going to have the request ID in the HTTP header. So if you need to diagnose, you know what request ID value to use. This tool which I have here, send-to-bridge.exe, is actually printing on the request ID over here. Okay, so this says message sent successfully, which means that we should now be seeing this lead in Salesforce, and yes, we see it over here. Name, company, and the lead status, open, not contacted. So we now have our end-to-end application working with using all the 3 extensively points which we have in the BizTalk service. So one thing is, in the current demo, what I did was I configured the entire WCF endpoint configuration by just opening up the XML file. If you use the SPC config editor.exe tool, you need to just make sure that your DLL, which contains your custom inspector, is in the location from which this SPC config editor.exe can find it. Else, it will not be able to show up your behavior in the UI. Again, add the WCF extensions to your config file. So one thing to keep in mind is that in WCF, right, you have a machine config file which is on your machine. You can always add WCF extensions in machine config. If you do that, what is going to happen is when we actually show you the config file representing your destination, the extension is not going to be there because the extension is already in machine config, right? And it's like hierarchical. WCF uses machine config, then uses your application config and combines them. If it finds the extension in machine config, it is not going to add the extension to your destination. So when you deploy the bridge, the extension information is not going to be there. So what you should remember is that when you're writing your own custom WCF extensibility to use in bridges. Don't define the extensions to machine config. Instead, add those extensions to the destination config as I was showing you in the demo. Let me just show you that again. You need it to be showing up here. Unless it's here, it's not going to be available in BizTalk services. And as before, again, either you upload the assembly using the BizTalk services portal, or you can just add a reference in your project, and when you deploy, we will deploy the DL. So just to recap, these are the three places where you have extensibility. You have message inspectors, which execute between stages. Again, in my demo, I only showed you the request, the one-way bridge, but if you have the response bridge, you could also have inspectors running on the response side. You can write C# functoids in the XML transform activity, and you can extend using WCF destinations. So I just want to briefly cover some of the futures as in like what we are thinking of, how to expand on extensibility. So this is futures only for extensibility and only extensibility in bridges. Okay. So the first thing is sources. So we have out of the box, we have FTP, HTTP, and SFTP, right? In BizTalk server, you had things like you wrote your own custom adapters where you could pull from LOB applications. The same mechanism is probably not going to work in the cloud because in your pipeline, in your bridge, which is running in BizTalk services, you don't have access to your LOB applications, right? They're really running on-premise. So we need to figure out how to actually allow you to do extensibility for sources in BizTalk services. So one thing, for example, is if you have attended the hybrid talk today morning, where we talked about how we use the BizTalk adapter service, where you can push a message from a bridge into an on-prem LOB using the BizTalk adapter service. Similarly, we need something on the source side, where you have a BizTalk adapter service running on your premise. It is pulling messages from your LOB, and it is pushing those to the bridge using HTTP. So we need to find a way to make it easy for you to use BizTalk adapter service and immediately and like very quickly set up a source, which is pulling from an on-premise LOB via service bus relay, or well, not service relay. You can directly push via HTTP into your bridge. So that is what we are looking at for extensively for sources. For destinations, as we saw, we have WCF extensibility. You also have the BizTalk adapter service, which we showed you. One limitation in the BizTalk services 1.0 is that the BizTalk adapter service on the destination side is currently only working with adapters which we ship in the BizTalk adapter pack, which is SAP, CBIL, Oracle. We want to make it such that if you write any of your own adapter based on the WCF adapter SDK, those adapters can also work with BizTalk adapter service. Then we come to artifact types. So currently we support 4 artifact types. We support schemas, we support transforms, we support certificates and assemblies, right? That's the pieces which you need to get your bridge to work. Let's say I wanted to write a component which converts XML to, say, PDF, right? In my Excel to XML conversion, it was pretty simple. Why? Because my inspector took my Excel document. From the Excel document, we figured out the XSD. And so the inspector could say, okay, from this Excel document, this is how my XML should look like. Let's say you want to do the reverse, XML to Excel or XML to PDF. I have an XML file. I need to populate an Excel template. So I have the appropriate data and appropriate cells, right? How can I do it? I need to have access to my Excel template stored somewhere. So just like how, if you look at XML validator, when it validates a message against an XSD, the XSD is an artifact available which has been deployed. You need a way to actually deploy an Excel template. So you can write your custom inspector or your custom activity that says, okay, for this message, because this message is a lead or this message is a customer or this message represents a purchase order, I must use this Excel document and convert and populate the Excel document, right? So we need a way for customers, ISPs to actually write custom artifact types so that we can expand just beyond sources, just beyond schemas and transforms and what we support out of the box. Pipeline templates is, so what you saw today is like we have an XML one-way bridge, there's an XML two-way bridge, there's also the pass-through bridge which we saw. On the B2B side, you actually have B2B bridges. You don't see them directly, you actually work with B2B agreements, but underneath there are really B2B bridges which you use. These bridges are using fixed templates in the sense that they're fixed because the type of the sequence of processing which they do and the type of processing they do is fixed. You can extend them at certain points by your inspectors, but let's assume you have a case where you really need to have some custom control flow, like you want to have like some sort of if-else logic in your bridge template, right? For that, you really need to be able to control the control flow inside a pipeline template. So that is one thing we're thinking about. So it's a future thing that we will allow you to actually customize the control flow inside a pipeline template. We saw functoids. Today it's like a C# scripting functoid, so it's like something which you write as a script. We want to make it easy for you to write reusable functoids, so that you can just drag and drop them from the surface into the mapper. It's kind of like how I think BizTalk supported custom functoids, right? Yes, we don't support BizTalk services yet. That's one thing on our future plan. I've also mentioned lookup providers. So we saw that out of the box we have a lookup enrich. Currently it only works with, think of it as like a SQL table lookup. We want you to be able to write your own custom lookup. For example, you might need to go and look up some external web service where you have to specify some data in the URL and get back some response value. You might want to actually, for example, execute a store procedure to get back some data. So we want you to be able to write your own lookup providers so that you can use an out-of-box lookup activity. You just configure your provider. You implement some methods that say how to do a get, like how to do a key value lookup, and you can just easily hook that into the bridge template. So that's futures, and I think I am done. Most of these sessions are already done, except the introducing Microsoft BizTalk Server 2013. It's tomorrow morning. Tomorrow morning at 10:15. That's B344, the fourth one. Oh, okay. The session number has changed, so please look that up tomorrow. And yes, we are done. Okay. Please fill up your evaluations. Thank you.